Okay, so Planet 9 is a speculated object that it what happened years ago. Uh, these two scientists named Trujillo and Chad Trujillo and what was his name, and Shepard, they noticed that a bunch of objects that are beyond Pluto, um, these trans-neptunian objects shown here, um, seem to be shepherded into uh, um, in a certain way that might be indicative of perhaps a giant planet beyond Pluto that is causing them to um, have this presentation. And Sedna, that you see there on the left, it is another object that really can only be explained if by a giant planet hurling it into this elliptical orbit that it's in. There may be some other ways of explaining it, but the most likely explanation for the Sedna, in particular, is that a giant planet pushed it in, threw it into its elliptical orbit. So you may have heard that there have been challenges to this hypothesis. Some scientists, in particular, let me just take care of this background image there. So, look, I'm getting ahead of myself before we get to the challenges. So Trujillo and Shepard said, "Oh, we think there might be a planet out here causing this." And a few years after that, that was in 2014. In 2016, Konstantin Batygin and Mike Brown at Caltech, they proposed that this Planet 9 hypothesis that was also talking about the shepherding of six specific trans-Neptunian objects and into the orbits that they were observing. So it was a bit controversial to some astronomers because it's like show us the evidence kind of thing. And it turns out that if Planet 9 does exist, that it would probably be dimmer than 23rd magnitude, which is dimmer than almost all of the surveys. In fact, it is dimmer than virtually all the big surveys that are out there. 23rd magnitude is very dim, and a lot of people, they're like, well, how come we haven't seen Planet 9 yet? We should have seen it by now because it's a planet, right? It's bright, and well, it's not. It's not bright, and there have been adjustments by Mike Brown and Batygin, who modeled this. They did do a lot of 3D modeling to try to calculate where Planet 9 might be. And let me open another image here. So over time, what's happened is more and more objects have been found after the initial six. Let me turn off that back animation thing because that's going to probably be too distracting. Yeah, that's the one. Okay. So more and more stuff kind of supporting the argument has been discovered beyond Pluto. So the reason they call them trans-neptunian objects is that um, because Pluto got demoted as a planet to a dwarf planet, which ironically is related, exactly related to this subject, which I'll get into that in a second. Um, um, they pretty much have the metric that because Neptune is the furthest giant planet, and you know, basically everything beyond Pluto that's a trans-Neptunian object is is going to be called a TNO, including Pluto. So Pluto is technically, it actually comes inside the orbit of Neptune a little bit for a short period of time, but it's considered a similar object to the Kuiper Belt objects, and is considered by many to be a Kuiper Belt object, which are these objects that orbit just beyond Neptune. So anyway, as you can see in this graphic, which I'm going to stretch over my image here so that you can see it, Planet 9 is this green arcing orbit, which you can't see my mouse. But the green orbit there is Planet 9. And you can see that all of these objects, the way that they're inclined relative to the solar system, seems to imply to some people that that a planet that is about 5 Earth masses might be orbiting out between 300 and 700 astronomical units. So about an astronomical unit is the distance of Earth to the Sun, which is approximately 91 to 93 million miles. So an astronomical unit is 1 Earth distance to the Sun, and this hypothetical Planet 9 would be beyond 300 astronomical units, and more likely around 500 to 700. So the distance has been adjusted a couple times by Batygin and Brown before, before tonight. But after what they announced it in 2016, and then they adjusted their calculations and moved it a bit closer to us. So the current thinking by those two scientists is that it is probably the closest it gets to Earth is 300 astronomical units, and the furthest out it gets is perhaps around 700 astronomical units. So now, that said, that's what Batygin and Brown have said. Other astronomers, kind of in support of them, have argued for ways of discovering it, and have seen other characteristics of the trans-Neptunian objects that make them think that there's a Planet 9 out there. And then there are these other two astronomers, which makes the story much more interesting to me, who are Carlos de la Fuente Marcos and his brother Raúl de la Fuente Marcos. They are astronomers who have proposed that there's not one, but 2 planet-sized objects out beyond 300 out beyond Pluto. So the first object would be the closer in one, would perhaps be a Mars mass object that is affected by the second larger object that's further out and is in what's called a mean motion resonance with this further out, bigger planet. And their models, they're professional scientists and part of a computational research center in Spain, and are also accomplished scientists. They are also professionals who observe through a 10-meter telescope and through other large professional scopes, and are respected. So a lot of people don't know. Like if you talk to the average amateur astronomer, and probably even professionals, they haven't even heard about this. But because I've paid attention to the subject over time, I have read their papers, and it's, if you go to Wikipedia article on Planet 9, their hypothesis is in that Wikipedia article for Planet 9. So I think that would be a good idea for me to open up that page right now. Let me see if I can. Because that'll help refresh me like on points that I'd like to touch on too. So let me go to Planet 9 Wikipedia. There it is, and let me promote that window or close this one. Let's see. This one. Yeah, I like this one. What's this? I will get to this window. Let me at my window. Is it this one? I'm just going to start closing out windows here, so give me a second. I have so many windows open that everything's kind of masked here. I've got Beetlejuice windows open. I've got movies, animations, one thing at a time. Yeah. So many. Holy smokes. Okay. Am I there yet? Can I touch my... Yay, I'm there. So there, Planet 9, the Wikipedia article. Okay, so let me fix this window here. I think I can resize it a bit. Scroll it over a bit, maybe. Okay, come on, baby. Come on, baby. Let me max that window. Show me the bottom. It's not showing me the bottom, so let me just pull this over here, move it over here, and zoom it over here. There we go. Okay, I just wanted to embiggen it. So, okay. And let me just look at my chat window a second so I don't ignore anybody. Where is it? Here it is. Okay, so feel free to ask any questions if you like. And let me talk about Planet 9. So, Planet 9 is, as we said, it's a hypothetical planet. It's not proven. We don't know it's out there. As you can see here in the middle of the article, I had mentioned Chad Trujillo and Scott Shepard in 2014, and was talking about Sedna, being affected by something, and you could see those two gentlemen I just referred to which are Raul and Carlos de la Fuente Marcos. You can see they're listed there. I think my mouse is visible. Is it? There it is. So yeah, Chad Trujillo, and then Raul, and Carlos. So we had just been talking about that. So you see, Raul and Carlos, right? They were talking about two massive planets, right? Um, in order to reproduce these things, and that, you know, if it were there, that the nearer one would be 300 to 400 astronomical units away. So that is, you know, that's pretty far, and it would be extremely dim. If it were a Mars that is at over 300 astronomical units away, we would not have seen it yet in any of our astronomical surveys. It would be too dim for us to find. So if we look at this path here through the sky, which I'm going to get out of this Wikipedia thing here. Hold on a second. Let me zoom out. And so as you can see, we were talking about Betelgeuse earlier in the stream, and okay, everything's good there. As you can see on the left here, let me make this bigger. Come on down. Okay, so you can see on the left here, here's Orion, right? And we were talking about Betelgeuse before. Well, this planet 9, this hypothetical planet 9, this is where it is traveling through the sky under one model that was proposed by Batygin and Mike Brown. And so they took the Subaru telescope and were looking in this area on a number of nights, and were unsuccessful in finding it, so far as I know. And you know, did a very in-depth look at this whole region, even up through Aldebaran, which is up here in Taurus, the constellation Taurus. They looked at, let me see if I can make that bigger. Come on, baby. So now it's stopped embiggening for me. There we go. That's a funny word, isn't it? So Aldebaran here, you can see in Taurus, the bull, which is this V shape that you see, which is, this is the bull's eye in Aldebaran. And Mike Brown and Constantine have been looking in this general region with the Japanese Subaru telescope from Japan, which is in Hawaii, and it's very expensive to do this kind of research, and it's also very hard to get observing time on a telescope, on a professional telescope, especially one that has the characteristics of the Japanese Subaru telescope, which has one of the largest, if not the largest, it was the largest, I don't know if it still is. It might have been replaced by one by the European Southern Observatory, but it has one of the largest cameras in the world, so it can look at a large chunk of sky within the constraints of the optics on the telescope. So they've focused their energy here, right? They're looking in this in this, here you can see on the bottom here, they're showing this 6 arc minute, I think, wide swath of sky that they looked at in going through this region, and they're, you know, they didn't find it, and so that was their best shot, right? that's like that was where they thought it was most likely to be, and it wasn't there. So that doesn't mean much, because the search space for where so I'm going to open a different window to give you an idea of how big the search space is for Planet 9. So give me a second. Let me think about this for a second. So Mike Brown has his own page on this. Mike Brown, Planet 9. Let's see. Look at how small that is. Holy cow. Not this one. Where is it? It's something like, where is Planet 9, or something like that. Hold on. I haven't been to it in a few years, so give me a minute here. Let me find it. And plus, he had a blog going. Yeah, he could have closed it for all I know. But better yet, let's go over to boy, it's become so hard to find stuff on the interwebs these days. Let me try a different thing. See, not the other ones. Let's see. Okay, this is Mike Brown. Let me see if he's got a website up here. Just a moment, please. See if he's got it on the footnotes of this page here. So yeah, I don't even know if he has it up anymore. Oh, Find Planet 9. I think that's what it was. Find Planet 9. So yeah, it looks like he might have gotten rid of it, taken it down. Fascinating. So, let me see, .org. Let's see if it's like, even then it's gone. So I think he may have taken it down. That's fascinating. So Mike Brown is, if we go back to his Wikipedia page, he's one of the proponents of Planet 9. And let's see if I can find his wiki. Where is it? Holy smokes. Okay, here we are. So, yeah, he has been like the biggest proponent of it. And if you notice on his page, he proudly says, he refers to himself as the killer of Pluto. So this is the guy, like the main suspect. If you guys, wish Pluto was a planet, this is your man who can be attributed to being one of the main proponents for it. Like, he argued at the IAU to have Pluto demoted, and his Twitter handle is at Pluto Killer. So he's proud of that. So not only is he the Planet Nine proponent, like one of the main ones, but he also um, discovered, as a co-discovered Eris, which is a trans-neptunian object, and which um, I believe is more massive than Pluto. It's not wider than Pluto, but it's more massive. Like it's denser and more massive than Pluto. So he also contributed. I don't see it listed here, but I'm pretty sure that he also, here's his discoveries, right? So you see this is his list of minor planet discoveries, right? So he's not a crank, right? He's been doing this a while, and if we scroll down this list, right, a lot of these objects, like Maki Maki and Eris and Haumea, I mean, these are large trans-Neptunian objects, right? They are the reason that he argued for for Pluto to be demoted. And he said, we're going to find a lot more of these objects beyond Neptune and Pluto, and we probably shouldn't call them planets because they're extremely tiny. Like Pluto's like the size of the United States. It's tiny. Uh, um, and he, his further argument was that, well, he didn't make this argument. I make this argument that if he hadn't had it demoted, that he would have been one, then all of these objects, especially Eris, Maki Maki, and Haumea, and Sedna too. Sedna, I mean, look, Sedna, Quarwar, Sedna, Orcus, Maki Maki. I mean, all of these objects, he was a co-discoverer or a primary discoverer on, and he would have been the most prolific planet discoverer ever, because all of these would have had to have been promoted under the IAU rules at that time to planets. They would have Sedna and especially the more massive ones like Eris and Maki Maki and Haumea. They would have been promoted. He would have been the greatest planet discoverer ever. So for him to demote Pluto, he removes himself from being the greatest planet finder of all time. So that's the irony of Mike Brown's story. Is, in my view, it's pretty ironic that most people don't know. So he's maligned by some as Pluto Killer or one of the people responsible, but if he hadn't done it, he would have been the number one planet finder, or one of them, because of the large objects that he did find. So he is also, it's most likely listed above here, he is also somebody who has been contemplating this Planet Nine subject, and let's see here. So you see here it says proposed ninth planet. So in 2016 he proposed, along with Konstantin Batygin, Planet Nine, and they go through the reasoning there, and arguments can be made that it doesn't exist, and there's a team called by the acronym OSSOS, AOSSOS, that puts up an argument which I believe is here in the discussed in the discussion here for Planet 9. So the OSOS team, let me go on, it's in this reception, I believe. Oh, here it is. So, where'd it go? Zoom back out, reception. Where is it? There it is. Where'd it go? Okay, so this Outer Solar System Origin Survey Team and the Dark Energy Survey Team, or OSOS, they argued like there's a bias in the way that these things were detected, and because of this bias, Mike Brown and Constantine are, they're not getting the big picture basically, and that if you take a bigger sample, like 800 trans-neptunian objects in the OSOS and in Dark Energy Survey, another 316. If you look at those, then this clustering doesn't seem evident in the data. Ever since then, though, so what's cool about science is you have to have dialogue, and there has to be challenge, right? Yeah, and you have to. No one can come out as an authority and say, that they are the authority in X, and that this has to be true. In science, you have to have dialogue and let people make arguments and destroy their arguments if you can. And it's what I like to call a sci-fight, a science fight. And so this OSOS team basically put up the challenge. They're like, hey, you guys have biased data. You're wrong. And so the counter argument came out afterward that it was the OSOS people who had too small of a sample, and that their survey had these biases in it. So Mike Brown and Constantine went back over their stuff, and they countered. They said that the probability of let's see if I can find the quote here. So they gave like an actual probability at like 98%, I think is what Mike Brown said, and others, those are the kinds of odds that they think it is. So based on going back and looking at the biases and ruling out, but well, on the bias thing, they think that's 99 point something percent, but on the overall hypothesis, it's like a 98% chance. So they basically ruled out that bias was causing the clustering that they observed. So that's a good thing, because if we look back at I still have, it's amazing how many Crab Nebula things I had open. Holy smokes here. Okay, hold on a second. Let me reopen my Planet 9 images here. So click OK, and then I want to also, I'll be back in view in a moment. I just want to reopen some windows here. So we get back to one more here, which is the animation for Planet 9. So, what we're looking at here is hello again. What we're looking at here is Planet 9 perhaps is perturbing these objects, and a number of that were discovered since this proposal came out that fit the profile of being objects that were disturbed by, that might have been disturbed by a planet. Other arguments could be that there's a massive disk of objects out in the, beyond Pluto that are affecting these other objects in a combined way, a collective gravitational way of warping them into the observed clustering that they're showing. And that's like another of the arguments that you encounter in, like, for what else could it be. So one of the things I'm going to try to show you guys, like, having Planet 9 solves a bunch of problems, right? If you don't have a Planet 9, there are a number of things that arise that can be solved by Planet 9. So, I'm going to make this a little bigger, if I can get to that window. Is it this one? I hope it's this one. Yay. So you can see here when they talk about evidence, right? So in the center, you could see here that if there were a Planet 9, it would explain 4 like major scientific problems. One is this clustering of objects that's still unexplained, and the counter arguments against it didn't hold water after further looking at them so far. They may still pan out if other evidence comes along, but at the moment, it seems that Planet 9 might be, or 2 planets could be a good explanation. So you can see here that it also solves for the Sedna being its orbit being explained, because it's a highly eccentric orbit that goes out, not this one, yeah. So let me take a look at this here. Where's Sedna in this graphic here? Should be, oh, it's this one. I believe Sedna is the green. Is it the green one? Can't see it. Oh, there it is. It's the pink one. Yeah. So if you look at the pink orbit here for Sedna, right, or the peachy pink one there, that orbit gets explained if there's a Planet 9, and we don't know why Sedna is where it is. A lot of trans-neptunian objects are explained by Neptune, right? Like they are in resonance with Neptune, and we could tell like their orbital periods are some ratio relative to how many times Neptune orbits the sun. These objects orbit in ratios relative to Neptune, but Sedna is what's called detached from Neptune. It's not resonant with Neptune. So really the only thing that seems logical for it at the moment is that that a planet 9 in this green orbit here would explain it. The other thing is the high inclinations of the extreme trans-neptunian objects. So that's what they mean by ETNOs, by the way. I'm sorry if I was like going into jargon and lingo. Hold on a second. So here you can see that they talk about ETNOs, right? These extreme trans-Neptunian objects. And by extreme, that means they're like further out. They have highly eccentric orbits that are ellipses that are very oblong, you know, like ovals. And they, in order for them to get into those orbits, they usually have had to have interacted with a large object in order for that to happen. And some of them, you know, are like Sedna, are almost hyperbolic, which means that their orbit is almost like if you just push them just a little bit more in their speed, that they would leave the solar system. And in order for them to have such highly eccentric and highly elliptical orbits, really you need a big object to do that. So Planet 9 solves this problem. Another one that they list here is, so the extreme trans-Neptunian objects are not in the Kuiper Belt. They're beyond the Kuiper Belt. They're way further than the Kuiper Belt, which is, you know, I mentioned before that Pluto is technically one of the Kuiper Belt objects. Those are like, you know, like at 100, they're at like 30 AU and 100, was it 100? It's not even 100. It's let's look at that. Hold on. Let's do ETNO on Wikipedia. So, okay. Of course, you get all the bizarro stuff. Hold on a second. Good thing I don't have graphics on, right? Hey, let's look at some images. Get banned from Twitch. So ETNO, extreme trans-Neptunian. Let's see. There it is. Now we're talking. So let me just look in on chat, make sure everybody's happy. Hi everybody. I'm Jason. Feel free to ask any questions, chat any questions. I'm game for any astronomy question, and I love astronomy, and I love to help people learn more about the things I've encountered along the way. So this extreme trans-Neptunian object subject, right? If we look at this chart of stuff, right, out in the solar system, right? So on the bottom here, you can see it shows 30, 35, 40, 45, 50. This is hold on a second. This axis is their perihelion distance. And let's hold on a second. I don't want to do this chart yet. Or maybe not at all. Give me a second here. Okay, so oh look, and they even mention, fascinatingly enough, you know, so here's the ETNO article, right? They do talk about Planet 9 down here in the article, which is kind of interesting to me because that wouldn't have been a thing a few years ago. So so here you can see Sedna, right? And these other objects that are extreme trans-Neptunian objects, they're way the heck out there. I mean, way, way, way out there. And their orbital periods are in, the hundreds, and some objects in the thousands of years of orbiting. And so you see, it's not a rare thing. But what they did is they drew here this blue ring of Planet 9. And I really, think it's interesting. And it may be, again, it could be a sampling error, as pointed out by some people. Like, I don't think you can really 100% rule it out. But it does seem kind of peculiar here, like that. A large percentage of the stuff that's further out, that has longer arcs, is somewhat opposed to Planet 9 here. So, and that they're you can see, like, their orbits, as compared to some others, are opposite and to Planet 9, versus all these red orbits filling in this gap here, where Planet 9 is. It's almost as if they can't be here. So like, that's an interesting aspect of extreme trans-Neptunian objects. Now, don't get me wrong, there's a lot of stuff out in the solar system, in those places that hasn't been cataloged yet. We just don't know. We don't have a full survey yet of this outer region. And if we look at this this graph here, you can see there's somewhat of the same thing, right? Like, all this stuff is kind of opposed to where the Planet 9 would have been. So it's very sus. Let me zoom out a little bit. And again, a lot of these objects were discovered by Mike Brown, ironically. So, they list these blue objects added by Mike Brown and Batigan. Okay. Close-up view of current ones. Okay. So, so the point is that there's a lot of stuff going on out there, and Planet 9, is one of the leading, in my opinion, one of the interesting arguments that could be made. The other one, I think, this Marcos, Carlos de la Fuente Marcos, and his brother Raul de la Fuente Marcos, I think their hypothesis is very interesting too, and it really surprises me that almost nobody knows about, unless you go to the Planet 9 article on Wikipedia, almost nobody knows that there are scientists who have proposed that there could be a Mars mass object out like 300 astronomical units, and another object even more massive, like 700 astronomical units out, or further. Give me a second. I want to see, without like doing any copyright violation stuff here. Okay. So I see on the Planetary Society that they show the largest known trans-Neptunian objects here, and you could see Pluto relative to these other objects, speaking about, Pluto being demoted, and um, these are all way smaller than Earth's moon, right? These these objects, and um, Eris, which I think is maybe misrepresented here in this planetary society image, um, is more massive, but I don't believe that it is wider than Pluto. My recollection is that it is less wide. So they are wrong. Okay, here we go. So let's go to the Wikipedia representation, which is probably a little better here. So you could see the objects comparison-wise, and how oblong Haumea is. And a number of these were discovered by Mike Brown, the proponent of Planet 9, like one of the proponents. Sedna is from him and his team. Maki Maki, they don't, and Eris, right? Haumea, right? Like if he didn't demote Pluto, he would be like the king of planet finders. So you got to give him that. There we go. So let me. I do want to show a graphic that's like this. Let me see if I can find one that's not gonna get me dinged here. Okay. Maybe if I just do regular trans-neptunian tune in wiki and go to all. I mean, they probably have the graphic I'm after. Here it is. I knew it. So let's see. So this is great, and I'm glad that we found this. So this, let me just look in on chat again. Everybody's cool. Excellent. So this graphic here, what's interesting here is, so we're talking about extreme trans-Neptunian objects and trans-Neptunian objects. So the extreme ones, right, aren't even on this chart because they orbit further out than what's represented on this chart. These are the things that, and I'm going to point it out here. So we have Saturn, Uranus, Neptune. These centaurs are asteroids basically that orbit in, at the distance of Saturn, Uranus, and Neptune, right? Then we get out to Pluto, and you can see Pluto, its orbital distance, its average, median distance, is in the Kuiper belt. Like it's a Plutino, right, in its own belt also, but it is considered a Kuiper belt object by many people. So many of these objects beyond Neptune, right? So Neptune orbits at 30 astronomical units. You see up here. I'm going to make my graphic bigger for you guys so you can see what I'm talking about. So Neptune orbits 30 astronomical units out, or 30 Earth-Sun distances away from the Sun. So the Sun would be in this direction, let's say, and it's 30 astronomical units out, Neptune, right? So Pluto comes inside, its orbit comes inside of Neptune and then goes out here, right? And so it is one of these Kuiper belt objects. And as you can see, relative to in size, comparative size to these other objects displayed here, you can see Pluto is big. These are mass, by the way, not size. And Eris is out here in the distance. It's orbiting like 67, 68 astronomical units out, right? It's out there a bit. And a lot of these other objects are way out here. And you could see, interestingly, in the Kuiper belt, there's a whole ton of stuff here. And then once you get out here, it's really sparse. Like there's not a lot of stuff out here. And this is, like a curiosity out to like 100, I think it's 100 or 120 astronomical units. There's not a lot of junk in this gap here. And then stuff starts showing up again. So there, in theory, there might be something clearing that stuff away. We're not sure about this yet. And there's a bunch of speculation about it. But these objects that are Neptunian, most of these are in resonance with Neptune. These objects here, a lot of them are they're affected by Neptune, and their period, their orbital time around the sun, it is usually connected to Neptune's orbital time around the sun. So if we look at the ETNOs, see if it comes up. Yeah, it came up the first time this time. These objects are, much further out. Like the Kuiper belt is in here relative to where like the Kuiper belt's the Kuiper belt is like this stuff. There's Neptune's orbit is like way the heck in here. This stuff is way, way out. If we look at like Sedna as an example, let's see if they have an orbital representation of it here. Here it is. So this is Sedna, and this object's like way the heck further. Now, let's look at the stats on this thing. What's its distance here? Where is it? So Sedna, right, comes as close as 76 astronomical units. We were looking at that chart that kind of stopped at 70 astronomical units for the trans-neptunian objects. Well, Sedna, the closest it gets is at just outside the edge of that other chart. So it's sorry, because I've been covering my face a long time here. Sedna is way the heck out there. It's like way in the boonies of the solar system, and as you saw in that graphic below, it's not even the furthest one. It's here, this graphic here. It's in here, right? The inner solar system's over here, and this 2015 TG387 is like way the heck out there. So what were we going to say? Oh, so getting back to the stats on Sedna. So you see Michael Brown's name is listed here, is discovered by Michael Brown, Chad Trujillo, which, by the way, is the one of the other people who proposed a planet beyond Pluto. This Chad Trujillo guy here, and David Rabinowitz. So they were co-discoverers. So it's this kind of a small community of these planet these object discoverers beyond. So they're dwarf planets, right? Some of these, and technically Sedna is a dwarf planet under these definitions. And as you can see, Mike Brown, he shows up at the scene here. So you need a Planet 9 to solve for Sedna. It's like there isn't another good explanation for why this thing is where it is. And excuse me, I am interested in looking at this other thing here. Hold on a second. I'm just curious about the stats on this other puppy here. So that 2015 TG387. So I did find it in another language. Let's see. Oh, this is its official name. They've been getting very inventive with Hawaiian-based names on these objects. So, okay, so let's see. Trujillo and Shepard are the discoverers of this, right? These are the other two. So in 2014, they proposed a planet, and then in 2016, Brown and Batigan proposed. So here they are, another group at the scene here. Trujillo and Shepard and Tholen, right? So that's an interesting name, Tholen. So, excuse me. So let's look at the, oh yeah, that's the Goblin. Okay, I remember this. So a while back, I actually went to a university that's here in Florida. FIT has a telescope, and they teamed up based on a prompt from me, and we looked for the shadow of the Goblin, this specific object, a few years ago. So it's it's funny then come back around to the Goblin here. Like I said, I'm an amateur. I'm not a professional, but I know professionals, and I also communicate with some of them. So this object was doing an occultation and was going to put its shadow over part of the Earth, which happened to coincide with Florida. So we gave a look. We tried to give a look for it, but we encountered technical problems at this. I think it was a 0.8 meter telescope. It didn't work out. I wasn't operating the telescope, but they were very kind and nice people there at that observatory, and very respectfully, they did a good job at trying to get at it. So anyway, what I would say is this object, which is further out. Let's look at how far out it is. It's like 2,106 astronomical units. So that's 2,106 times Earth-Sun distances away. So that puppy is way the heck out there. And its orbital period is 35,760 years. So it takes that long for it to do that. So to make one orbit around the sun. That puppy, it makes Sedna look like our next door neighbor, and Pluto's like in our closet. So yeah, yeah, that's kind of cool. I wanted to go look at that because I was like, I remember like there was an object. So yeah, the Goblin is I mean, how do you explain that one too? Because it comes in, it's perihelion, right? So you could see here, it's aphelion, which is the furthest it gets from the sun. that's the helion part, the helios, like the sun, right? And ap is the farthest, like the is it the Greek prefix? Uh, it is its furthest distance is 2,106, but its perihelion, the closest it gets to the sun, is 65 astronomical units. So the closest it gets is like right inside that other chart we showed with the ETNOs, the not the ETNOs, the trans-neptunian objects. It just comes barely into that view and then it goes back out again. So this thing is, again, another thing that is too far to be resonant with Neptune, as far as I know, and that's a big leap I just took. But let me see if it is. Just give me a second here. I think they would have described it if. Oh, okay. Oh, we got to look at that too. That's kind of cool. Hold on. But first, let's go out there and see what's going out there. Whew, it's crazy. I was just reading some of that, and I can't get into those subjects right now. Or we'll just go down so many rabbit holes. So hold on a second. Well, we'll talk about some of these other things in the future, but let's just here's a visualization by them of, like, if you were out at the orbit of this thing, this 2015, the Goblin, right? Like, you'd be looking in on the solar system, and even this graphic, I think, is a bit generous of a graphic. I mean, it would be I'm sorry, it would be way in the heck. It wouldn't even look like that. The scale is not represented by that graphic by a long shot. So here it looks. This is the observation of, like, what its path that it traces through the sky. So it gives us, like, back and forth motion because of the Earth's path around the sun. And when you take an image of it when the Earth is at one side of its orbit, and then you take an image of it from another side of its orbit, it will appear to trace this path over the sky relative to those background stars. Let me just make this a little bigger so you can see, like, if you were to try to find it with a telescope right now, like where it would be. So you can go by the amount of loops here of how many years it is. So here, this is 2018 right here. Oh, let me see if I want to show you guys my mouse. So here's 2018. And so if we just do like 1, 2, 3. Okay, so this is 2018, 2019, 2020, 2021, 2022, 2023. If you were to look about in this spot in the sky with the telescope relative to these other stars, and Algenib is a well-known star, you would find this very, very dim sednoid object out here. Let's see what magnitude it is. It must be, like, ridiculously dim. Let's see here. So its apparent magnitude is 24.5. So that is dimmer than every survey image, like big survey, like the Pan-STARRS or the Palomar survey. This is deeper and darker. Like, it wouldn't show up in those surveys. That's how dim this thing is. It is out there and is very, very dim. So let me look at chat real quick. Oh, hey, Misadventures in Astro. How's it going? Sorry, I didn't look in on chat soon enough. Yeah, so we're talking about Betelgeuse and the end of its carbon burning cycle, and as mentioned in a scientific paper that came out this week, um, uh, and I saw it mentioned by Fraser Kane on YouTube uh, later in the week. And so I did some looking into that earlier in the stream. And then a little bit later, I was talking about um, how Betelgeuse is likely to, when it becomes a supernova, it will likely collapse into a neutron star. And neutron stars, the ones that we know of, are usually become um, pulsars. And I was comparing how a pulsar, um, so the Crab Nebula pulsar is akin to what we might see if Betelgeuse collapsed into a neutron star. Because the Crab Nebula progenitor star was around 10 solar masses, and in this paper that came out recently, um, what would be one of the closest pulsars? The Crab Nebula. Yeah, the crab. So yeah, the M1, the Messier one, and the what I was showing people was that this pulsar. Um, let me just. Yeah, that's something that I don't think anybody has realized. So it dawned on me. I have to explain how it happened because to me it was kind of a cool thing. So a lot of people malign AIs, right? Like the new GPT-4 experience. And I was chatting with Bing Chat about what would happen if we put Betelgeuse at the distance of if we put the Crab Nebula at the distance of Betelgeuse. So it gave me a response. It was slightly wrong in the math related to it, but I did the calculations after that, like the inverse square calculations on the energy levels. And so yeah, as if Orion is another cool nebula. Yeah. Well, here's the freaky part about that, and let me show you, because I talked about it before, and we'll get everybody will get back to the Planet 9 subject in a second, but I do want to show, in case people missed it, I have to show this because it's kind of interesting of a thing. So I had done this calculation here, right? Where if you take the Crab Nebula and you see the intensity there is one intensity of Crab Nebula at 6,500 light years, right? So if you move the Crab Nebula to 600 light years, it becomes 117 Crab Nebula intensities. So at 600 light years. So today, the Crab Nebula, its energy is as strong as, well, it's variable actually, but I didn't know that there was this unit of measure called the crab, or millicrab, and I discovered that this week. I was like, oh, let's see, crab unit. Let's see if that comes up here. So there's this unit of measure that is in Crab Nebula. So I was like, oh, that's kind of cool. So it turns out that the energy of the sun at solar maximum is 2 crabs, the X-ray energy. So at solar maximum, and the strongest solar flare that we've ever felt is let me open another image here. The strongest solar flares that we see are 7 crabs, right? So get this. So the graphic. Oh, hold on. Let me open something else here. That's cool. Hold on. So, here's the Crab Nebula spinning in the background here. I'll close that for a second just so that we can focus on this thing. So, what I had open before was not that one. Is it this one? Where'd it go? I lost my thing. Here. Oh, I got too many windows open. Too many windows. Here we go. What's this one? Oh, this one's funny too. So you got this. Let me promote this image here if I can. Image. Let me move this to the top. So here you got this pulsar sweeping over us, right? It's this is the Crab Nebula. It's a pulsar that sweeps over us and is flashing. So the strongest solar flare. So if you look at that calculation thing that I was showing before, which I'm just going to open another window of it because I can't find it in my stack of bazillions of images here. Let's go track it down here. So this thing that I was talking about before, what we're saying here is that if you move the Crab Nebula to where Betelgeuse is, so basically Betelgeuse becomes a neutron star, becomes a pulsar, and is flashing over the Earth, that it will be 117 times the intensity of the Crab Nebula, which is like it's 58 times the solar maximum that we feel, which is 2 crabs. So it's 58. It would be like if Betelgeuse goes supernova and becomes a pulsar, it would be like having a continuous 58 times the solar maximum here on Earth, which that blew my mind, and I was like, let me see if I can close this window now. Please close. Or better yet, let me try to delete this window. Even better. Hold on. Let me just get rid of it altogether and see if I can. Where is this window? I think it's this one. And now we're going to get to the other images in a second here. So I will take this off the screen though here, just so that's not a distraction. Let's close this out. Wow, I have just too many windows here, too many windows. Let me close this up. Yay. I feel better now. So let me go back to chat. I apologize because I was just looking at all these other things. Yeah. So yeah, it is kind of cool. So what's the point? What I was able to show, I think, is that if it does go supernova, and there was a recent paper about that. Let me open it up. Open with this, and re-grab that window if I can. I will get control of this, please. Is it this one? Yay. Okay, so this paper is the one that was discussing that Betelgeuse might be at the end of its carbon burning cycle imminently. So this came out this week, and is, I think it's like, if now, of course, scientists are gonna challenge this, and rightly so, but if their hypothesis pans out from what they were describing here, it would be a really big deal, because, as you probably know, Betelgeuse was recently brightening a bit, and it's also been unstable with the dimming in 2020, 2019, 2020, and the recent brightening, which we now can't really see it very well because it's closer to the sun. So yeah, if you look at this thing that I pulled up on the screen here, you can see what they were talking about, and they're, that's interesting. I thought so. That's why I got back on this subject. We had recently had a stream where somebody put up, a question related to Betelgeuse. It's like, oh, what do you think about Betelgeuse brightening? I was like, well, let me tell you. And so that one I was talking about the actual supernova and the polar jets, from that, and the risk associated with that. But as you probably have seen, a lot of people have said, oh, well, we're far enough from Betelgeuse to not really worry about it. But I think it's reasonable to say that the pulsar is what we should be worried about, not the supernova. I mean, we should be worried about the supernova, and by worried I mean there's nothing we can do about it. So worried in the sense of, like, I don't want to be looking at it when it pops, kind of thing. But it would be a bad hair day if that happens, I think. So yeah, so we were talking about that, and then we got into the Planet 9 subject, which is what I'm going to resume now for a little bit. And so what we were talking about on the Planet 9 subject was that scientists like Konstantin Batygin, Mike Brown, Chad Trujillo, and Scott Shepard, and a few others have made the Planet 9 hypothesis based on modeling of the orbits of extreme trans-neptunian objects. And I was saying that it is, if you look at in particular, if you look at Sedna, which is one of the extreme objects, the only Planet 9 gives like a really good explanation for it. And so, we went over to the Wikipedia article on it so that I could prompt myself on things that I've experienced over time, but also one of the things that they get into is this gravitational influence thing. So and what, why is it important for us to have a Planet 9? And what you see here on these four things, there are other reasons too, but these are the four big ones. Um, and perhaps like one of the biggest ones are the very detached objects. There's no reasonable explanation for them. So yeah, so this other facet that they point out that we were looking at in the orbits there was it talks about the high inclinations of Etnos is perpendicular to the plane of the solar system, and it's like that, and it's not easy to rationalize that. There are people who have tried to say, well, it's a sampling error, but people have looked at that afterward, including Mike Brown and found that it wasn't due to bias. And I don't think there's been a counter challenge, a counter challenge from the OSOS team or the teams that were challenging that. So before we were also looking at this graphic, which kind of was flying out away from wow, I just have so many windows open. I'm going to start. Pardon me a second while I do some house cleaning, because I really want to just get back to not being distracted with that. So let me just remove all these windows here. Yes. Give me a moment, please. I just have to get a whole bunch of them. Here we go. Clicking away here. So many. Unreal. Because I could reopen them later. I just cannot. I don't even know what they are because they're so hidden. So so we're looking at this, right, and we saw how things are opposed to Planet 9 on the initial 6 that were discovered, and then later on, other objects have been found that are, consistent with a Planet 9 explanation. So we touched on that, and then it's good to do a recap sometimes, I think. Let's close. What is this window here? Who knows how these things get where they get. And let's get back out here. Escape. And so and we looked at this before too, and we were showing that after those initial 6, there were quite a few other extreme trans-neptunian objects found, and many of them, but not all of them, but many further support the Planet 9 hypothesis. Now here I could see in the article that what they're doing is they're comparing. I'm going to show this up close here. So there's an exoplanet that has a Jupiter mass object orbiting out away from its solar system, like its inner solar system, at a distance that is similar to what would be hypothesized for a Planet 9. So this is, it would be way more massive than a Planet 9, because Planet 9 is, by Mike Brown, they think it's somewhere between 5 Earth masses and maybe a little bit bigger, maybe 6 Earth masses, or up to just under like a Neptune mass one. But this is a Jupiter. I think it's like a super Jupiter too. It's like many Jupiter masses. But the point is that they did find an object that orbits in a similar distance and elliptical in the same fashion that Planet 9 would be too. So, it's supportive. And as you can see in the graphic, I'll try to make it bigger. You can see that this on the left here, the size of Neptune's orbit and relative to this image, it would be in here, right? Is like this is where Neptune would be. So this one that they found is supportive of, we know it happens elsewhere. So that's a positive thing. Oh, so I'm back on chat. I see chat. Hold on, let me. Sorry I missed the chat there. So let me take a look here. So, oh, cool. Didn't realize that. As if Orion needs. Okay, I read all those. I see what you're saying with the orbits. Yeah, would have to be a decent size as well, correct? Yeah, so for Planet 9, yeah. So one of the things, so it's five Earth masses as proposed by Batygin and Brown, who, by the way, downsized it from 10. When they first proposed this, I recall it was in 2016, they were saying it was 10 Earth masses, and they moved the orbit closer in and smaller based on a lot more modeling. So they've been using a lot of supercomputer time to do many iterations of orbits over the span of the solar system, and to simulate like where it could be in the sky. And they came up with like it's probably like 5 or 6 Earth masses, something like that. So that's their hypothesis. And then there are these other guys, Raul and Carlos de la Fuente Marcos, and they're Spanish astronomers who have predicted that there might, in their modeling, and they're computer modelers and they're professional astronomers, big league professionals, and they think that there could be a Mars mass planet out around 300 AU, and another somewhat more massive one like around 700 AU, like further out, that is in an orbital resonance with this Mars mass one. So that's an interesting thing, and it would be so hard to find because it would be incredibly dim. If it was like a Mars-sized object, it would be like very hard to find. So, thinking science here, right? You have to have, in order to have a theory, it has to be testable. So, coming up, so how do we find Planet 9, right? Like what methods are we going to use to track it down? So there are a number of telescopes that are coming online that one of them in particular that has a chance of it showing up in surveys, and so also Mike Brown and Constantine try to get time on the Subaru telescope as much as they can. But it's the Japanese are very courteous and kind to have given them as much time as they've gotten. But it is um, you know it is somewhat unlikely that that they'll get enough time to do what they want to do to find it before this other survey comes online. So stay tuned, so to speak, for it. A thing I want to show, because I encountered this, which I thought was pretty cool. So, like, how can we get involved in the search, right? Because we're just like normal people or amateurs. So amateur astronomers don't generally stand a chance on this. Oh wait, I can see chat. Um, um, what's the solar evolution theory of how these largish objects might form? I mean, if we've seen one example, it probably means it's super common. Yeah, so we've seen a couple of examples in addition to the one that I was showing you. And then for this particular one of the hypotheses was that Planet 9 was a protoplanet when the solar system was forming, and it was between the orbits of Uranus and Saturn, or was it Uranus and Neptune? I forget which one. And it got ejected from the solar system. And math models, like, this is an old, I remember in the 1980s, this idea about rogue planets being thrown out into space was a thing back then. So we now know that that's a fact. Like, we see ejected standalone planets out there without suns, right, that have been thrown out of their solar system. So one of the hypotheses related to, I see the right there, that has been put forward for Planet 9 is that it is one of these things that has been ejected out and somehow didn't have enough force to be hyperbolic and leave the solar system. So that's like one of the big ones. One of the other options that was put forward was that it was a captured object from either a passing star, or it was an object that was disturbed by a passing star that was orbiting further out. So it could have been a planet orbiting, so the sun, when it originally formed, it formed amongst a number of other stars, and then there are stars that periodically come close to the sun, disturb the Oort cloud, which is this cloud of billions with up to a trillion cometary-like ice balls that orbit way out, and it may have either disturbed an object that was in the Oort cloud, or donated an object to our solar system from its solar system. So that was another proposal that for why a Planet 9 might exist. So what I want to, there's this, I saw that, and I think I saw it here under citizen science. Here it is. So check this out. This is so cool. So this backyard worlds, which is like under the Zooniverse thing. So let me make my screen bigger so you guys can see this. So this, people like us can, and I don't know if my whole screen is visible to you guys. Let me see. I might be wrongly sizing this. Hold on. Okay, well, I'm going to leave myself covered for now, and So this universe thing, let me grab the link and copy it here and put it into chat. Okay. There we go. So there. This backyard worlds thing is where people like us can look through images to try to detect objects that are moving in the background in images from actual images that are being taken. So you have you can see down here that 75,000 volunteers have done 226,000 classifications. There are 30,000 subjects that they want to look at, right? But there are only 10,900 completed. So if you join, it says here on the left, there's still no substitute for the human eye for picking out subtle motion out of the noise, right, of these images. So one can join the Zooniverse project, which I'm going to click over here, and you can see Zooniverse. A lot of people have heard about it, zooniverse.org, and they are doing a whole bunch of different projects that people can get involved in related to arts, biology, genome, climate, medicine, all kinds of stuff, right? And physics. Now, what's interesting, if you go to the physics, you don't see the one that we were just looking at, right? Like they have Galaxy Zoo, which I used to participate in that years ago, but and they're doing Planet Hunters. Like you can join the search for undiscovered worlds, right? That's kind of fun. So you're looking at transits of planets in front of stars and watching the dimming, and then you pick out this pattern and help them to find stuff. So you see it's only 47% complete in this, and they're looking through TESS, which is this transiting exoplanet survey satellite, where you too can help in looking through this large data set of subjects. Here it's 11,800, 158,000 classifications, and only 5,600 completed subjects out of 11,000. So that's where they get the 47%, right? So so one can get involved with not just looking for Planet 9, but also for looking for exoplanets. So that's kind of cool. Let me go back here. Did Galaxy Zoo? You did Galaxy Zoo as well. Yeah, right. I did that when they first came out. I was clicking away, and boy, like it. For me, I'm just speaking from experience, it got monotonous, and it was like, I have other things that I want to do. so I kind of forgot about it for a while, but Galaxy Zoo was fun because you're classifying the shapes of the galaxies and the way they present, and for a lot of them, this was a true fact, is you were the first human to ever look at that galaxy in the data. And to me, that's like awesome, right? Because you're the first human to ever set eyes on it, because it was buried in the survey of jillions of objects, and like, I think that's just like so cool that you'll be the first person to see it. Like, what? Yeah, right? Never thought about that, right? But that it's true. Like, you're the first one. Like, if this is like an observer-based universe, right? You made like that wave function collapse, right, by looking at it. So if there were no organisms there, right, and nothing to to observe it, so yeah, it's kind of cool, and I you're welcome, everyone, everyone in that galaxy, right? Send me a thank you card. So you better watch out because you might have a intergalactic time traveler come thank you personally. So yeah, so somebody monitoring the matrix, right? So yeah, so we have so yeah, so I think this is kind of cool that you can help in the search. So here's I'm gonna I don't know what's on here, and I don't even think the audio is gonna play from it. So let me see how it goes here. Okay, is it playing? I think it. Wait, let me see. Let me see if it's playing or not. I hear it in my headset, but I'm not sure. I don't think it's playing on for you guys. Hold on, let me look at chat here. Oh, okay. So anyway, they're just playing music, so I don't need it. I don't need the audio. So let's look at this. I can just go up here. So let me, if I hear any audio, I'll comment on it. That like verbiage or anything, but let's see here. In a way, it's good the music isn't playing because who needs a copyright strike, right? So let's see. It's going out and out, right? I haven't. Yeah, Pluto's the king. Okay, that's interesting. I hadn't heard that one before, but yeah. Okay. No one knows its exact position, mass, or size. Finding it on the minds of astronomers and citizens alike. This is a 3-minute video, so bear with me, and let me go see if I can open up my chat window while this is going on, so I can see if anybody comments. It says, "You're welcome." No, okay, I saw that. So lack enough mass for nucleus, so they are born grow colder over time. So NASA's wise, but recently. Okay, so yeah. I know about that. Let me zoom ahead here. So they're just they're telling us about these objects here. Okay. Right. Sorry, I don't have any music on, guys. So let me just zoom ahead here. So yeah, it's looking for Planet 9 and brown dwarfs, right? So that's the gist of that. Is that you can help them. So they also have this graphic here of how brown dwarfs are much smaller than our sun, which is on the left background there, and just a bit bigger than Jupiter. So yeah. So here's a good graphic here. I'm just going to digest this with you guys. Let me just, because I haven't seen this page even before. Yeah, so that's interesting. Okay, so yeah, so what they're saying is like there's supporting evidence, and there's other stuff too, right? There's um, not just the Planet Nine candidates, but other junk out there too. So someone felt bad for Pluto calling it king. Yeah, not even the biggest. We know they're right. Yeah. So before we were looking at that too. Just give me a second here. So we were talking about for the extreme trans-neptunian objects. So they had a graphic here of the sizes, I recall. Or am I wrong? Oh, it was just TNOs, maybe. Yeah, here it is. It's this one. So this graphic, right, they were showing Pluto relative to these other trans-Neptunian objects. And, you know, in the visual, like Eris is more massive than Pluto. It's not, oh, those dipoles. Yeah. Yeah, so if you're talking about, are you talking about the spin axis that they're showing, or the rings around Haumea? Because yeah, these things have rings, a lot of them too. Um, um, some of them are not represented here either, but yeah, but Pluto, you know, relative to Eris, right? Eris is slightly less wide. Just the times. I had to classify dipoles. Okay. Yeah, yeah. So you could see scale-wise that Eris and Pluto are kind of similar. And before uh, right, in star surveys. Oh, okay. Oh, wow. Uh-huh. Yeah. Before regarding these objects on the screen here, Sedna, Makemake, Haumea, Eris, all of these objects, not all of them, but the ones I just mentioned, Mike Brown, who put forth the Planet Nine hypothesis with Konstantin Batygin, was responsible for discovering these other objects beyond Pluto. And his argument to the IAU, the International Astronomical Union, was that if you call these things planets and the new stuff that we're going to find, because undoubtedly there will certainly be more discovered over time, that some of them even slightly bigger than Pluto possibly, that, you know, if you call then all these things have to be planets too. And Pluto's like, you know, like the size of the United States. It's not that big. Our moon is bigger, you know. So his argument was, you know, if these then everything's got to be a planet out there. So the irony is you know, like we were showing before in the Wikipedia articles, is like Mike Brown's name keeps showing up on the discoverers and co-discoverers thing, and his Twitter handle is @PlutoKiller. So if he, you know, like he's kind of proud of that, but I don't think that's a good thing, by the way. But but the irony of it is, if he hadn't done that, you know, just looking at these objects here, he would have been the greatest planet discoverer ever. So or one of the co-discoverers ever, because many of these other objects would have been called planets, and he, you know, then Claude Tombaugh only got one, right? But he would have had many. He would have been like the super planet finder. so the true king of of etnos and TNOs. So so even though I won't get into other things related to that subject, but I would just say that you got to give him that he took a bow, a knee, basically took a bow, uh, in for the sake of like saying these things are minor, But for me personally, like people, I want my cake and eat it too. Yeah. Well, yeah. He could have done that, right? He could. Yeah. So let's see. I wish we could call them planetoids or something. So here's the deal, right? In my view, right? And everybody's got their own views, but they are dwarf planets, right? They still have the word planet in their name, right? They're dwarf planets, and you could stand on them, you could visit them. They're round. They're planets, right? They're just dwarf planets. So you could say that they're planets. They're just dwarfs. so so I they have satellites too. Yeah, yeah. You can see here they all do. So all the big ones. So and probably there was another object that New Horizons visited that almost became a binary. Uh, it's a contact binary where it's touching and stuff. You can see it's got like two lobes on it, and so stuff out there tends to be. There's usually some other junk orbiting around it or near it or in contact with it or has merged with it. Yeah. So yeah. So um, let's see. I was talking about New Horizons spacecraft, which I heard recently that they were kind of trying to repurpose the mission. To keep it funded or something, which that's it's like the only thing out there that can do what it's doing. So I don't know if I'm like if that's a cool thing or not. But where's this? So of course, excuse me. New Horizons visited Pluto and did like zillions of gorgeous images of Pluto, like this one here, where you could see the hazes and fog. There, it says view image feature. Let's see how that works. Okay, there we go. So there's Pluto, right? I'm gonna make it a little bigger. So it's got its own atmosphere. Like you could see the haze from it. It's not something we could breathe. Wouldn't want to live there, but you can see it's got terrain. If you stood there, it would instantly like vaporize. I think the ice is hard as rock, and it's in all of our hearts. It's a planet, right? So. I think that's pretty cool. So yeah, we were talking about New Horizons. So it did. Let me see if I can find. So one of the other things that New Horizons, it has a telescope on it, and to try to find stuff out ahead of it, and it hasn't been successful in finding like a good candidate for another thing to go to, and it has this. This heat source that it gets its power from, so it could, it could last for a while if, if it could just find something to go to. So so after Pluto, right? It also had discovered this other object we were talking about that looked like, kind of like a contact binary. Let's see if I can find it here. Yeah, New Horizons is a trip. Oh yeah, these are other satellites of Pluto. You had mentioned these other satellites. So look, here's like Charon too, a moon of Pluto, and it's like kind of an awesome little moon. You know, considering how small it is, I think it looks pretty neat. And yeah, pardon me, I was just looking at chat, and so what I wanted to show was this contact binary, which I guess is down at the bottom here somewhere. Thank goodness for Wikipedia, man. Some people malign it, but it's so cool. I mean, the best educational tool and around. Here it is. So this is that object. You can see it looks like somebody glued together this thing, and you know, it is barely together, right? It's just like somebody crazy glued it to each other, and so that I think that qualifies as a contact binary. I haven't read that paper, but if it isn't, I'd be surprised. Let's see, Arakoth. Yeah, that's the name of it. So yeah, so stuff out beyond Pluto is gonna be like cool to look at, to discover. Let me press this, and hopefully nothing crazy happens. So here we go. This is the flyby of Pluto here. Let me try to make it bigger, and this is when they did the flyby. They're showing like the details on the surface on Pluto. I mean, it's a place, right? You can go there. You could go skiing there. you could do stuff there. You can refuel your spaceship on the way out. Look at those too, how they got resurfaced. You know, it's an active. It's not only, you know, a planet. It's got active processes on it. Like there are no craters in this area that can be seen, right? And let me get out of this video here. So yeah, there are no craters there, so it's resurfaced itself. So it's got active cryovolcanism, it seems, or active, not plate tectonics, but active resurfacing for sure. If we look here, this is a nice little video of Pluto there too. So yeah, beautiful places. So think about it. So like Pluto is typical, let's say, of these large trans-neptunian objects, and perhaps typical. And if it is, like, you have all these places that have potentially have subsurface oceans. Pluto is suspected of possibly having a subsurface ocean, and could be the reason for the resurfacing that we're seeing there. So I'm just trying to minimize my way out of here. Sorry about that. And so yeah, so that, you know, multiply that times the very many likely other objects that are out there, and you have a lot of possibilities for interesting stuff to happen. And so yeah, let's come back around to I want to say carbonites. Oh, okay, I'm gonna read your tweet. Sorry about that. Your posts. I'm sorry. Yeah, is that ice? So yeah, ice on, if we were talking about all those, yeah, so all of the trans-Neptunian objects, yeah, it looks like nitrogen and methane ices. Yes, that's correct. Um, um, and there's even water ice out there. Just Google it. Yeah, yeah, and there's water ice on some of these too. So it's volatile. If you threw Pluto into the inner solar system, it would become a comet. It's like that. That's how volatile it would be. It would look like a big comet, and that's what happens with a lot of trans-Neptunian objects too. Is like stuff that comes in from the outer solar system, trans-Neptunian objects, stuff that comes in from the Oort cloud. That stuff is is oftentimes it's they're all ice objects, right? And they have rock kind of mixed in with them, but they um, they evaporate once they get close enough to the sun. So virtually most of the ones that you see, I'm going. Why am I going to YouTube? Right? I'm going to go over to show you guys something related to what I was just saying. So, is it here or is it on my other one? Oh, it's on my other one. Okay. So let me go over here. By the way, hi everybody. I'm Jason. I do amateur astronomy. I talk about the universe. I help people to get into astronomy. I show people the universe through telescopes and through what we're doing right now. So here it is, Comet Ison. So some people may have seen this in the past on my stream, but I want to show you like what happens when a comet, oops, I just clicked out of it. Just give me a second. I'm just trying to make it bigger for you guys to see. So the comet on the left here, the big one on the left, is the comet Ison, and it came in for the first time from the Oort cloud, which is this cloud of icy objects. Literally up to 1 trillion of these are out there. Way out. Way further than the ETNOs, even, the extreme trans-Neptunian objects. And so it got jostled perhaps by other objects or perhaps by a passing star at some point, and slowly made its trip into the solar system. And this is its first pass in. And then the other object you're going to see here, which I believe you could see my mouse, right? So this is Comet Ison, and this is Comet Encke. And Encke is a periodic comet that orbits the sun every 5.6 years or something like that. It's 5 point something years. This one here. So this one has been getting worn out, so to speak, because it keeps orbiting the sun, and the volatiles that are on the surface are evaporating off of it and flying into space. But what's cool about this image, I made this video from stereo satellite images when Comet Ison was coming in and literally melted at the sun. And I want to show you guys, because this is, to me, is like one of the tippity top, like, coolest things I've seen in astronomy. There are a couple, and if you stick with me through time, I'll show you them all. because there's quite a few. But this one is up there on my greatest hits thing. Is if you look right, so here it is, it's flying in. I'll keep my mouse away so you could see. You see, it's like puffing up and blowing its tail away from the sun is on the right, and these two comets are flying in, and they're both blowing their junk off into space, and then this closer in jump right here is the same comet Ison's coming in and passing the sun, and watch, it goes and it evaporates and is done. It's over for that one. So it got a little too close, and that was it for it. It made one trip to the sun, and that was it. But on the other hand, this comet Enki is still orbiting the sun because it didn't get as close as the other one. So it didn't rise again. It just it bit the dust, so to speak. Became dust. So yeah, I'll just do one more of it going by, because I can't get enough of this. I made this a long time ago, but this comet, by the way, picture this: if it hit the Earth, it would be catastrophic, right? And there are over 1 trillion of these things out there, right, getting jostled. And we don't have a clue when the next one will come in and where it will hit, when it will hit. We don't know. So, don't worry about Betelgeuse becoming a supernova or a pulsar, because stuff like this could get you too. As the universe, who was it? I don't know if it was Neil deGrasse Tyson or who said it, but the universe is trying to kill us. It's a busy place out there, and there's so many things that could get us. We shouldn't worry about like these giant catastrophic events. Yeah, see, that's my credits there. We shouldn't worry about. This gives the information, though. I'll let it play out here. Okay. Okay. So let me get out of this. Okay, all the way out here. Here we go. Way out. So, got away from chat for a second. Let me go back in there. Very cool video. Oh yeah, you have to. Yeah. So that's one of the things over time. I'll be able to show you guys a lot of other fascinating facets of things I've come across over time. And let's see here. So what I want to do is wind down here on the Planet 9 a little bit, and we'll be able to summarize here and close it out here. So let's get. I'm going to go back to this page because I want to see if I'm missing like a main point that I wanted to touch on. Let me just go through here. So read the Wikipedia article on Planet 9 if you want. It's a decent article, and it'll give you the rundown of where the name came from and stuff. So let's see. Would the material get blown away by solar winds and potentially collect back in the Oort cloud? So the material will blow away, and it will probably not have enough energy to escape the solar system, but whether it got swept up by something else, it could. yeah, it could. I don't know if it would make it all the way back to the Oort cloud or not. It might have enough momentum to do that. Probably it does, but it probably wouldn't leave the solar system. But yeah, it could. It could. Um, that's the link to this Wikipedia article, and then I'm just going to scroll through here and see. We talked about citizen science. Oh, there was another thing. Oh yeah. So yeah, this other project um, using Zooniverse too. They found 4 Planet 9 candidates that they were going to follow up on. I don't know if they did follow up on it or not. Let's see. Oh, okay. And then the searches with an existing data. So I'm not going to dwell on this very long because I want to wrap it up. They, but I would say that I participated in a personal search in existing data um, of other surveys, and worked with others on trying to digest what I was doing, and then uh, there are some surveys that I still want to look through, but I'm running out of time because a new survey is coming online that will basically make all these other surveys obsolete. And um, but what would be a good search would be to use an AI to go through the Pan-STARRS surveys, the Dark Energy Survey, and a few other ones, and um, an AI, because it's a daunting task. I found zillions of candidates in the stuff I was doing, and the problem is ruling it out as being Planet 9. Like you found something, but the difficult part is um, the what's called the cadence has to be just right. Um, the interval of imaging in the survey has to be in a fashion that allows you to rule stuff out. And some of these don't lend themselves well to that, or they don't lend themselves well to recovery of the object later on when you're. So let's say you find it in 2015 images, but like you can't recover it in later images because you're not sure of the arc of its orbit. So I do want to resume that someday, but I'm self-employed, so I have to do, and I'm not a professional astronomer, so I have to do other things. But I would like that would be something I would like to do. So I have to find the time as an amateur to do that. But one can go into, if you know how to program, or you have good programming knowledge, you can go through these databases and try to find it yourself. Although I can tell you it's very difficult. Some of that, what I just said, has been tried by Mike Brown and Konstantin Batygin, but they have, if they had something, you would have heard about it. I think, unless like they're trying to build up actually imaging it, but sometimes these things leak out too. So, oh yeah, I see here. I just want to touch on another explanation for this. Could be a primordial black hole for this clustering of the orbits. Could be from a primordial black hole, which are these theorized black holes at the beginning of the universe. It's theorized that very small black holes could have formed that are, are free, that are not uh, as massive as, like a supermassive black hole in the center of our galaxy, and they would be very difficult to detect, other than for debris falling in them or them sweeping up dust and gas. So it's if there is one out there, it would be very difficult to find. And then there are these other more complicated explanations, some of which I touched on already, like the shepherding by a massive disk and that stuff. And then we got the reception by scientists, and there. So yeah. So another thing I would say before wrapping it up is Planet Nine. Why I'm interested in it is, so we already know that giant planets um, can have moons around them that can be tidally stretched and heated in their internal oceans. So they're ice balls of rock and ice, rock in the center usually, and ice on the periphery, like the moons of the outer planets. And this tidal heating creates oceans for stuff to live in. So, and it is perhaps even likely that although a Planet 9, if it were a Neptune mass one, would not be habitable, moons around it could be. And then if it's a 5 Earth mass one, now here's the interesting thing that a lot of people don't discuss, but I will, is objects of that size can retain incredibly large, massive atmospheres. And those atmospheres can make it warm enough for, and could make the planet not have cooled enough for it to be a useful environment for things. So, I think that if there was a Planet 9 out there, that it would be like, in my book, it would be, they say that Mike Brown has said we could send a probe there in 20 years. I think, if we use gravitational slingshot to get out there, that we could get there, that we could fly something by it in 20 years. And I think that would become like the highest priority. So the best bet is to look at thermal data for planet. Yeah, I think that's true, what you just said. So another friend of mine, who I haven't spoken with in a long time, but he's an amateur up in Washington State, and he came up with a method that is actually being used by professionals right now to go through the data, where what they do is they take, excuse me, they stack images and are able to pull out of the noise a Planet 9 using AI. So it's an interesting method. So there's a couple different methods that we might use, but the temperature thing, yeah, is a good possible way of finding it. Another way is, in addition to this big survey that's coming up, is if it has any kind of magnetic field, it could produce aurora, and strong radio signal. And recently there were an exoplanet's radio field was detected, albeit it was closely orbiting a star and interacting with it, but they were able to detect it. So, hypothetically, the radio footprint of, it is pretty, could be detected. And unfortunately, the JWST can't do the kind of imaging survey that would be needed to look for Planet 9 because its field is too narrow. It's sensitive enough, but it would take a tremendous amount of time that it doesn't have. So, but the ALMA telescope array is very high resolution. It's this Atacama large millimeter array in the Atacama Desert in Chile. Let me see, ALMA Chile. Okay, so here we've got the ALMA Observatory, and you can see all these telescopes in this image here. So all these little, and you can see the demand is like the top article, right? All these millimeter array dishes could find Planet 9 too. And the resolution is unsurpassed. Like, I think the only larger, better, higher resolution images would be like a planet-wide radio telescope or something, or if like they combine the dishes. So as you can see here, ALMA. Check out the work that these guys are doing too, because this is amazing. You need a lot of people. Some people need oxygen to visit this array because it's so high on the in the Atacama and so dry. So so this is another way that they could find it if they were to do some kind of if they had a clue like where it might be. This could zero in on it. And again, like they have to have a rough idea where it is in order to track it down, because the amount of sky to search is ginormous. Before I was talking about where it is in the sky, and I'll just touch on it for a second because in case somebody here wasn't here for that. But let me open that up here, this one. So this is the path in the sky of where in 2006 they estimated, Mike Brown and Konstantin Batygin estimated that it might be. And this is near Orion and Betelgeuse. It's near Taurus too. So you can see the years. In the year 2000, it was here in the image, and then so it's where 2020 something. It would be about here in their estimate, right? So they looked with the Subaru telescope. They looked. Mike Brown and Batygin looked in this area, all around this area, and up toward Taurus, above and through the region, and didn't find it yet. So that was with a really good telescope. I think the Subaru is an 8-meter telescope with the best camera, like wide field camera available. So they didn't find it there, and so I'll end it soon I'll do a wide shot photo of Orion and be happy. No, maybe it's there. Yeah. So yeah. So what I want to do is just give an idea of like the search space before I tried to. Um, Mike Brown had a website. Uh, I think it was called Find Planet Nine, and um, I couldn't find it in DuckDuckGo. Let me look in. I hate to use the G word here, but let me okay, yeah, I don't see it. So Mike Brown must have pulled that page. Altogether. Well, now I know, right? So the reason I was like trying so hard to find that is because um, he, sorry, I wasn't showing my window. He, suggested a window to look through, and I used to, I used to have that on my computer. Let me see if I can find it. This is going to be a little more difficult, but I will try my best to. I have to go into some real retro images here, but in the sense of like how far back I've seen this, so I'm kind of scraping the memory here, trying to remember where it is. Not this one. Got to go further back in time. Go to like backups of ancient machines here. Time travel. Okay, if it isn't in this one, I give up. Because the search space is ginormous. It is ridiculously giant. There we go. Yeah, I can't even. I'm not going to dig into the woods here, but I made a map too of this. Let me see. I even sent this to Mike Brown like years ago, and it was interesting. Oh, okay. I have Planet 9 orbit. I'm trying here. I'm trying to go as fast as I can. So, yeah, this will be good. So, Planet 9 orbit cropped. Hold on a second. So now I got to go open this. Give me a moment, and we'll wind it on this one. Let me open this image because this is a good one here. Let's go to. Here and almost there. I mean, it is like zillions of folders deep, so just give me a second. Okay. Make sure I got the right one. Okay, yeah. final JPEG. I hope it's this one. Let's open. Okay. I think you guys can see this. Hold on. Okay. So here I am. Just give me a second. So let me open up chat. Okay. Let me see. Okay. Got away from chat for a second. Let me see. I guess you just monitor the whole area and hope to get lucky or comb through historical images. Yeah, I did promise to try to come by. So let's see. Oh, very good. Yeah, Eosfin. I think that's how it's pronounced. So here is me. I and 3 new friends. Yay! Welcome. I'm Jason. I'm an amateur astronomer, and I show people the sky. Misadventures in Astro. Let me read what he just said. Maybe use known stars where we haven't been transit. So, right. So yeah, a transit search would also be good. That has the most sensitivity. Like offers like the most. This was another thing that same friend from Washington State had suggested. Looking for stars to blink out due to Planet 9. And so that would be a very wide field survey and very difficult to do too. But it would be worth it. It would be, that would be a good thing. So I'm just going to make this bigger. So tonight we were talking, for the new visitors, we were talking about Planet 9. Soon we're going to be wrapping it up. But what I was going to close on is this is a map that I made a while back of the original predicted path of Planet 9 through the sky. And I made this map based on the original proposals by Mike Brown and Konstantin Batygin. So what I'm going to do, I think, let's see if I can, so I don't see my mouse presenting on the screen here. So what I'm going to do is tell you that this yellow line that goes through the image there and through Orion in the center is the path that it could follow. And where you see the white circle with the crosshairs near Orion's bow and arrow, where his bow is, that is roughly where I came up with the estimate from Mike Brown, which is very close to what I was showing you before in that other image from Wikipedia. So as you can see, the path is very similar extremely similar to what you see here. You can see Taurus up above the white crosshairs thing, and that's where Mike Brown was looking in this general area. So imagine a swath that follows this through the entire sky and wraps around in back of us this yellow. So let me get back to presenting myself. So imagine this line, right? Which for you, I guess, is, let me up. So this line that we see here, diagonally going through the image, imagine a large swath parallel to that on each side of it going through the sky, and having to look through that much sky in 360 degrees around, even in back of us. And this is the chunk of sky that they need to look at. There are literally billions of stars in that that pathway that they have to look through and rule out, basically, and also rule out the many comets and asteroids and trans-neptunian objects and what they call the vermin of the skies, which are asteroids. Oh yeah, so mind sharing that orbit so I can stick it in my stellarium. So hold on, I'm going to think about that for a minute, like how I could get that to you. Yeah, so the vermin of the skies are the comets and asteroids, right? And why they call them vermin is because there's so many of them, and they get in the way of them trying to do like look at stars and try to do other look at transient objects that are flashing. It's like so some astronomers call them the vermin of the sky. So you have to rule out all these literally thousands and thousands of objects and billions of objects when you do the full catalog of it. So this diagonal path is a large, I think it's 30 degrees wide swath through the sky. It's very wide, and it can't be done right now, basically. Like this upcoming survey that's coming up will be able to do it, but they don't even have the computing power yet to process the amount of data that's coming from this new survey that's coming. Like they don't have, like, even if you do distributed computing, you still can't process this much information, and they're you know, they have to work that out. So we're ways away from ruling out Planet 9 altogether. It could be a thing. It might not be a thing. We think, based on Sedna's orbit and other orbits of clustering trans-Neptunian objects, extreme trans-Neptunian objects that are way out there, that that Planet 9 is a good explanation for that. One thing they thought it could have been explaining was the tilt of our solar system, but a recent study seems to have ruled that part out. So the solar system is tilted about 6 degrees away from the sun's spin axis, and originally they were thinking maybe Planet 9 sort of had like a cantilever effect of making the solar system be tilted, but it turns out that effect is only perhaps if there were a Planet 9, it would only be about 1% of the tilt. So we still don't know why the solar system is tilted the way it is. That's an open mystery. Yes. So let me look at chat again. Sorry, I had to close that window for a second. And let's see, 30 degrees. Wow. When can we start training a model on the new data? So yeah. If you hold on a second, let me take a look at that. So I have to reopen some windows here. Just give me a second. Okay, so let me close this window altogether, I guess. Hold on. Is this it here? Okay, there we go. So the Vera Rubin Observatory, which earlier was known as the Large Synoptic Survey Telescope, is the scope that could pull off detecting Planet 9. uh, let's see, so they show a completed rendering of it. You can see it's a big one, and um, let's see what the completion date is now, because that date, has slipped, and when COVID came, it slipped even further. And construction progress, okay, they suspended due to COVID. Okay, so they don't even dare saying what it is, but this is the survey that's going to do it, that they still don't have the computing capacity to deal with it. So if you look at um, um, this chart of telescopes here, let's see where the LSST shows up in here. So yeah, it's small. I don't even see it here. Where is it? I don't remember. Hold on a second. There's a model there. Oh, this is them casting the mirror. So they have had progress. I had thought that it was opening soon, but I'm sure that they had delays that pushed it. Oh, first light expected August 2024. I see it there now. Okay, so that would be cool. So yeah, so let me go back to chat. Sorry about that. Is that balance maybe from Andromeda? Maybe P10 and Jupiter. Take your time. I find it all very interesting. Oh, thanks, Eosfed. Yeah, so this telescope could find Planet 9, and it will image a very large percentage of the sky every night. Um, um, it, and I think it will have the biggest camera ever made for a telescope when it goes into service. So that'll be cool. And so stay tuned. It's going to take a long time, but because it's so fast and surveying so much of the sky, it, discoveries are going to come quick, and be a lot of amazing discoveries that come from it. So I for one definitely look forward to that. And so that's the Vera Rubin telescope observatory, excuse me, and one of the ways that we'll be able to track down Planet 9. So yeah, so thank you everybody for coming here tonight and visiting with me. Come back and check out, if you missed earlier in the stream, feel free to look once this is available on the archive there, and check out what we were talking about, because we also got into Betelgeuse earlier, and it going supernova and creating a neutron star that will create a pulsar that may affect Earth. And then also check out my earlier streams too, and feel free to ask me questions anytime in the future about astronomy, about getting into the hobby. I want people to discover things with me, and it's observe the awesome universe that we have all around us. And basically, I want you guys to have as much fun as I am. so yeah, thank you everyone. I think we could try to raid out now if you stay with me. I appreciate everyone being here, and look for me next Sunday night at 8 o'clock. that's my regular time, is Sunday, every Sunday at 8 o'clock. I want to increase it to more days of the week, and I don't want to compete with amateurs who who are in the same category as me. So I keep an eye out for that. And I understand that Astro Canuck might be coming back online this week. I saw that he scheduled something for Tuesday, so look out for his stream too. And for other astronomy streamers on Twitch too, and science streamers too. Thank you very much for coming here, and I look forward. Watch in the future. My next ones are going to be interesting ones also. On life in the universe, on new discoveries that have come out in very recently, and things that are new to all of us. So very good. Keep those stars in your eyes. Oh, thank you. I finally catch you. Have a beautiful night. You too, Aerosven. Thank you, Miss Adventures in Astro, and every space is fake. Hi, space is fake. Love you too. So, yes, I can assure you that space is not fake, and it is not only right over your head right now. Like, all you have to look up, but it's all around us, in front of us, as close as here. Space is everywhere, and we're not separate from the universe. We are the universe. So, your name is funny, and I appreciate that. But I appreciate good comedy. But I do see the Carl thing too. So you're not far gone. Carl can save you. So yeah, Carl Sagan was a famous astronomer. In case anybody didn't know about the Carl smile emote there, used by Space is Fake. He made the Cosmos TV series. Was a brilliant person. We are all made of star stuff, right? Of space stuff, yeah. And he also was responsible for helping to craft the Voyager plaque images, and the Voyager and the Pioneer. So these plaques that went out into the universe that are engraved with messages, those are flying out of the solar system right now, and Carl Sagan had a hand in that too, along with Frank Drake and some other people. And I've spoken with Frank Drake in the past. That'll be in a future stream. We'll talk about some of the things he had to say about life in the universe, about SETI, the search for extraterrestrials, about some other things too. And I look forward to our next streams. So thank you everybody for being here. I appreciate you all. And let me take a look in the raid thing, see if anybody is still streaming. Usually by this time in the night, all the people I follow are sleeping for work on Monday. So let me give a good look-see here. So nobody immediately shows up here that I would say, oh, wow, let's go to him or her. But let's see who we could find here. Okay, I don't see anybody there. I'm going to look for one particular streamer that does sometimes stay up this late. So I realize that it's still early in California. I apologize to everybody on west of me. I'm on the East Coast, so I only see people that are kind of close to my time sphere here. So yeah, it's like, oh wow. Okay, let me look at this one streamer and make sure she's doing something pretty chill right now. Let me go over there, see how she's doing, what she's doing. Okay, here we go. And good, that's not on stream, so I can see like who my faves are, if they're if they're on here or not. Okay, down. Oh, okay. Oh yeah, I see a couple. Okay, hold on. It's funny. Twitch doesn't offer me like all the people that I'm interested in, so that's fascinating. Okay, well, I could raid out to this guy. He's a trip. Let me see if he's even there right now. So he's okay. I'm gonna raid out to this guy. I think if you he's he doesn't he's only got 2 people watching him right now, but he's like this retro music guy who like develops music like these tracker software. Okay, let me listen to it. Hold on. Okay, yeah, I'm gonna raid out to this guy. Let me see if Twitch will let me do it. Hold on. Yeah. Okay. Okay. We're gonna raid this guy. Thank you everybody for being here tonight. The raid's gonna start in 8 seconds. Clear skies and good seeing, and we'll catch you next time. Here we go.